Hi, welcome to day 8 of 100 days of Common Lisp. So today's problem is to create a generalized version of a Caesar cipher, basically allowing encoding and decoding just by rotating by k letters, right? It's actually a simple problem. I'll show you the code, but I just wanted to take this opportunity to go into function arguments. It's not really needed for this problem, but let's just do it that way. I have the functions listed out here, but I'm just going to create them again in our REPL. So let's start with the most simple kind of form that we have already seen, a function that takes, say, 3 arguments, A, B, and C, and let's just print some kind of output just to use these variables, right? So it's I'm just using A, and maybe we can just have a new line here. And then you kind of pass in your variables just to use all of the variables that you're passing, right? Just kind of dump them. So now if I do f1 or format 1 of 1 2 3, okay, 1 3 3, so you see all of them getting printed out. Now this is fine, but what is the problem? The problem is if I only say pass 2 arguments, right, and it errors out because this number of arguments is not matching. So you can't really use to do things like optional arguments or things like that. So there are a few variants that Lisp provides. Let's go over them. These keywords, especially ampersand rest, ampersand optional, ampersand key, and default values. So let's go over them one by one. So the first variant is basically, let's go back to a function definition and let's define something else somewhat differently. So what we do is, let's say we take 2 arguments or 1 argument, and then we use the ampersand rest keyword here. And then you can basically give another variable. So I'm just going to call it O for others, right? So now what will happen here is, so now we have only 2 inputs. So let's only print these 2 inputs, A and O, right? So basically it looks like we're taking 2 arguments, right? But there's also this ampersand rest keyword. So let's see what it does. So if I call us with a single input, so what happens is it has 1 for A and the other one is set to nil because we didn't pass anything, right? If I pass 2, you see that the second variable O becomes list of 2. And if I pass something like this, that becomes a list again with 2 items. So the idea is it is going to capture the rest of the arguments, as many as you have, and all of that just is returned as a list to the user. So this is one way of doing variable argument passing, right? You can just grab everything else into a list. Now, the other variant is, as I listed here, optional, right? So this is more about, let's go back to a definition and make a new one this time with optional, ampersand optional. And you can have like basically multiple values here. And let's go back here and let's print all of them, right? And A, B, and C. So now if I just pass one input, then basically all the other inputs are being set to nil. And I can obviously pass more now. And B is now set to 2, but C is not set, and so on, right? So you can set all of them. So this allows optional inputs. Of course, here if I go and do this, it's going to still fail because we didn't really provision for more variables. So if you want, you could actually use both of them. So both of the things that you've seen so far, which is optional and then also rest clause to capture the remaining inputs. Now, with rest and optional out of the way, let's look at default values, right? So this is only going to be applicable in the optional case, not in the other cases. So if you use the optional keyword here, so I say keyword, but that's actually wrong, right? In Common Lisp, this is not a keyword, right? This is just a symbol which represents some kind of meaning. So I shouldn't be using the word keyword. Keywords are things that start with colon, right? And this doesn't start with colon. So in other languages, keywords are used that way, and I'm kind of making a mistake by using that same word here. You can think of it as a form, right? Maybe I should just call it as a form. So here I can basically pass in some kind of default values for your optional arguments. So if I do 1, 2, 3, this would take 1, 2, 3. But if I do just one like this, then b as an optional value of 10, and that is what is going to be used. Now you can obviously set up optional default values for all of your variables. So I could set something for C and so on. But you can see a flaw in this approach. You can't pass in C. For example, in this case, you have A and you have optional value for B and no optional value for C. And maybe you only want to pass in values for A and C, leaving B as the default, right? But you can't really do that because you have to give arguments in the order that you've defined. So that's where the last variant kicks in. So it's called ampersand key, and it's basically going to convert those arguments into keyword arguments, key arguments basically. So actually I can use the word keyword here because it actually makes sense now. So what I mean by that is, let's say we do this and we set, we use ampersand key, and that means everything that comes after this position is going to be taken in as keyword arguments. That means you can't use the existing version, you have to use it as keywords. So let's see what I mean by that. So what I mean by that is, this will fail because there is no key called to. So what you need to actually do is, for these arguments for B and C, this is sort of the syntax that you need to follow. So you have to use, now B is a keyword as in colon B, and that is going to take the value 2, and colon C implies that the argument C is going to take the value 3. Of course, because we had optional values from before, because we set optional value here, this means that if we don't pass in colon C is going to get the optional value that we have defined here as 20, right? Now the benefit of doing all of this is you can reorder the arguments. So I can do something like having C as 10 and B as 2, and so this is basically switching the order of the arguments because we are using the keyword. That's pretty much the benefit of using ampersand key. So you can obviously combine some of this, all of this together and work it out. Now let's go to today's problem, the Caesar cipher. I have purposefully used the keyword argument here. I mean, I didn't have to, but I just went with it. I wanted to introduce this concept in today's video. So here we're taking a single compulsory argument message, the message that you want to encode or decode, and the rest of it is going to be keyword arguments. And what we're saying is we are going to have an argument called OP, operation, and don't get confused with this colon encode, right? So what I'm saying is the default value for OP is going to be colon encode. So both are keywords. When you actually call this function, you have to pass colon OP, and then the value for that op would be colon encode, right? Because I want to do encode or decode. Now I could have used a string here or a normal symbol, but usually the Lisp way is to use a keyword. So I'm going to do that. And we have a variable called delta, which is going to basically just represent the number of spaces you want to rotate your cipher, right? Now here I've done a simple runtime check. It's a generic type check, but we have done a simple thing. We are just checking if the input value is a member of this list, right? It's going to be encode or decode. If it's something else, this is an assertion that will fail at runtime, and it'll just throw up a condition aborting. Basically, you have to abort the operation at that point. Now let's look at the actual logic. It's not very complicated. With all the concepts, I've used all the concepts that we have introduced in the last several days. So we have a loop. So let's start with the loop in the inside. And what we're doing is we're just looping for I across message, because message is going to be a string, a vector of characters. That's why we have across, and I would represent each alphabet, each letter. And then we have a collect of some operation. So we're going to do some operation with that letter, and we'll get another letter back basically, and then we would just collect that into a list, right? But now after I collected it, what I've done here is, because I don't want a list, I am actually, so you can see that the loop ends here. I'm going to coerce that list of characters back into a string, right? Because I want to return a string to the call. Now let's go into the actual logic of the rotate that is happening here. So I'm calling the other function I've defined here, rotate, which has two arguments. Both are compulsory, no default values, nothing. So there's a character and there is a delta, right? And now what we have done here is, if basically the idea is simple. If we're going to encode, we're going to rotate in one direction. So we're going to have the delta as whatever is the past delta. And if it's to decode, we are going to rotate it in the opposite direction. For the default Caesar cipher of 13, it doesn't actually matter. But for if you just use something else like 10 or something, then you would need to ensure your direction is correct. Now let's go to the actual rotate function, right? So it looks actually quite long, but it's not complicated. The complexity comes from managing letters which are not alphabets, right? So basically, we are assuming here that I only want to work with characters between A to Z and capital A to capital Z, and not the other special characters and things like space and so on, right? Because you don't want to rotate those. Like if there are words with spaces, we're going to leave the spaces as it is. I don't know what the real formula for the Caesar cipher is, but that's what I'm going after. Now we have these basically character codes, because we have to convert between characters and their ASCII values, so the codes. So I have these variables for the 4 endpoints, so to speak, and we also convert the current input character into its code version. And then we have an actual function here, which is very obvious, that if the character code, if your input character's code falls within the range of A to Z, then we run this with that code. Or again, if it falls between capital A to capital Z, we'll run it with this base. And else, if it's not in either of these ranges, we don't do anything. We just return the character back. Now, what are we doing here? In both cases, we are passing the offset, basically the starting point, that is A or capital A. We're just passing those codes just to use to manage the offset and rotation. The actual function is here, that's running, is run with the base. And what we're doing is, now if you see here, I have, for example, used the variable current because it's captured in this context. I could have passed it into this function also, but I've taken the lazier approach and just used it, just captured into this function. So what you're doing is we're just subtracting current from base. So this is basically your current position. So if your alphabet is small c, then you're separating it from small e and getting the offset from the starting of your location. And we're calculating a new offset from the starting of the same location just by rotating by n. And all this extra plus 26 mod 26 is just to ensure that it's within range, and basically managing the loop when you get to the end and start again. And then we calculate the new alphabet, the new character, by just again adding it back to the base. And we're converting that code back to character, so that when we return from here, we have the character going back. So this makes sense, right? So let's also try to run this just for completeness and evaluate this and go back. So the function name is Caesar cipher, right? So, and let's say this is the message you want to encode, and by default the op will be encode, but let's just to show you, this is what you need to do. And the delta is 13. Let's just go with that delta, right? And that this becomes this letter series. So now I can say I found a decode. So I go back here and I switch the messages, and that should give us back a value. I mean, of course, this was with the default cipher. So if I change the delta to something like 10, just for example, and let's decode this back. It's all obvious, but just to show you that everything is working. And if I also go here and have a space here to sort, you can see that the space is not getting mangled, and so on, right? So now if I just wanted to show you the enforcement, so if I, instead of using encode here, if I use something else as the argument, then that would fail that type check. Basically here you have no choice but to abort, but in the future we'll see with the condition system we might be able to like even recover from this and so on. So there is just one final observation I want to make here. So when I was writing this code, my initial instinct was to go with CA, like basically character code of A, character code of Z, and then like capital C or C capital A, right? Something like this. This kind of is what I would have done in any other language, but this does not work in Common Lisp because Common Lisp variables, symbol names, basically symbols, are actually case insensitive, right? This can be a bit jarring if you come from any other language, but what I mean is if you do this, you actually see when the symbol is being interned, it's actually capital A. It is already converted into capital A. So if I try to do this, right, uh, it's actually the same variable. I mean, look at this, you can see that this is the case. If I do, it sets a variable capital A, or like let's do something else. Let me make this very explicit. Um, it's B is small b is set to 20, and if I set capital B to 30, so that works, right? I mean, B is 30, capital B is 30, though we never created the variable capital B because they are both the same symbol. Uh, so this is the default common Lisp behavior. There's this nice Stack Overflow question on how you can actually change the read table to actually make it back to case sensitive if you want, but that's not a reliable thing to do because that's not how it works. As in most packages, by convention, everybody assumes that your variables, your symbols are going to be uppercased, so you can also kind of follow that convention.